Okay, guys, so we'll understand the various kinds of number systems that we have and how to convert from one number system to a different number system. Okay. Um, in our daily lives, in our daily use, we use the decimal number system a lot. But when you come across complex subjects and complex job roles, you're bound to go through or you're bound to come across different number systems, not just decimal. So, other than decimal, we have many number systems. In fact, we can create an infinite amount of number systems as per our choice. But there are a few which are universally accepted and which are used a lot. Let me list them down here. One of them is binary. The other one of them is octal. The other one is hexadecimal. And um, yes, there are many other than these, but um, um, what we use, um, the most used number systems are these four: decimal, binary, octal, and hexadecimal. All right. Now we'll try to understand all the number systems and how can we convert numbers from one number system to a different number system. All right. Decimal. So every number system has a base. Let us understand this. What is a base? Every number system has a base. Now, what's a base? Base is actually the number of primary digits a number system can have. Okay, the number of digits, or let's say the least numbers or the least set of numbers a number system can have is known as the base. For decimal number system, we consider the base as 10. Now, what does it mean? It means that we can have a set of 10 numbers in the decimal number system, and by using those 10 digits, or let's say 10 numbers, we can generate any number. So which are those 10 digits? Those 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9 are these 10 digits, and hence the base of decimal number system is 10. All right. What about binary? When we talk about binary number system, let us talk about binary. The base for binary number system is 2. Okay, let me explain what is the binary number system. So the number system used by most of the computers is binary. Why did I say most? Because as the technology is advancing, we are stepping into quantum technology, and we have something known as qubits. What are qubits? Qubits is more subtle form of bits, and bits are actually binary digits. Let's not get into the crux of this. Let's just understand that the binary number system has base 2. That is, we have two digits. Okay, so binary number system comprises of just two digits. And which are those two digits? 0 and 1. That's it. 0 and 1. These are the two digits which the binary number system comprises of. So the base of binary number system is 2. Okay. What about octal? What about octal? As the name suggests, oct is 8. So it simply means that the base of octal number system is 8. Alright. Now which are those 8 digits which are in the octal number system? 0, 1, 2, 3, 4, 5, 6, 7. These are those 8 digits which are included in the octal number system. So 0 to 7 are included in the octal number system. That is the reason why the base of octal number system is 8. Okay. Similarly, for hexadecimal, the base is 16. Okay, the base is 16. There are 16 digits. There are 16 numbers in the hexadecimal system. Let us see which are these numbers. Okay, so in hexadecimal system, we have 0 till 9. Okay, but what beyond that? We already know that hexadecimal number system has a base of 16. That means there should be 16 digits. Okay, so after 9 we have A, B, C, D and E. That simply means that we represent the number 10 by A, B by 11, C by 12, D by 13 and E by 14. And one more, there's one more, which is F, which is for the number 15. So what happens here is, instead of, see, in decimal number system we make use of 2 digits to represent 10. How is that? We take 1 and we take 0. So we are making use of 2 digits to represent one number, that is 10. But here in the hexadecimal number system, we are just using A to represent 10. Alright? So this is the use of, this is the use of using different number systems. Basically, when we are dealing with large numbers, it is better to take number systems which have which is higher base, and when we are dealing with smaller database or smaller data, it is good to have a number system with low base, like a binary number system. But there's no specific set of rule for this. All right, there's no specific rule for this that we should use this for a particular database or this number system for a particular database. It's not like that. So these are the basics of number systems. Now let us understand how do we represent decimal number systems. Let's say 79. This is 79 in decimal number system. Okay, but what if we feed this 79 into computers, modern day computers? We know that modern day computers understand the binary language. That means they make use of binary number system. For them, 79 won't be 79. Okay, and just to explain, what is this brace along with 10? So this 79 is in decimal number system. If I write 79 with brace and an 8, that means this number is in the octal number system. We'll get to this point later on, but for now let us understand that this is in decimal number system. Okay, now what if I have to feed this 79 into computers and generate a binary code or a binary number? Okay, that is when we need there's a need to convert this 79 into binary. Yes, into the number system which has base 2. How do we do this? So there's a rule for this which we are going to study now. Okay, there's a basic factor of conversion. There are a set of there are rules and methods to do such conversions, and let us see which are those. Okay, if we have to convert decimal to binary, okay, understand this, decimal to binary or decimal to octal or decimal to hexadecimal, just do one thing. Just do one thing. Divide the decimal number by the base that you want to convert to, by the base of the number system that you want the number to get converted into. For example, the base of binary is 2, the base of octal is 8, and the base of hexadecimal is 16. So just divide the decimal number by these bases. Let's say, for instance, our example is 79, alright? We have 79 in decimal. This 79 needs to be converted to decimal, binary, I beg your pardon. How do we do it? Decimal to anything divided by the base. Just remember this rule, divide by base. How do we divide by base? Let us see this. Okay, so here we have 79. Okay, so 2 3s are 6, and we have 1 carry, and 2 9s are 18. What is the remainder after I divide 79 by 2? It's 1. Again, 2 1s are 2, 2 9s are 18. Remainder is 1. 2 9s are 18. Remainder is 1. 2 4s are 8. Remainder is 1. 2 2s are 4. Remainder is 0. 2 1s are 2. Remainder is 0. Let me take this here now. And 2 zeros are 0. Remainder is 1. Okay. So this thing, let me adjust my pen first. This thing is here. Alright. Now what was the motive of dividing 79 by 2? Because we had to convert it to binary. Alright. We had to convert this thing to binary. And in order to convert this thing to binary, what we did was we divided it by 2 and collected this set of remainders. So these are the set of remainders. Okay, these are the set of remainders. Now what we do is we go from bottom to top. Okay, not from the top to bottom, but go from bottom to top for the set of remainders and note this number which has been formed. So what is the number? It is 1 0. Let's write it down. It becomes 1 0 0 0 1 1 1 1 0 0 1 1 1 1. This is in binary, right? So this is how we converted 79, which was in decimal, to this number in binary. So 79 is represented like this in binary. Now you see that in binary number system we make use of the digits that are available to us, that is 0 to 9. And in decimal number system we have just 2 digits available, which is 0 to 1. This is how we convert binary numbers, decimal numbers, into binary numbers. Okay. Now if we have to verify this, we can still verify it. Let's see how. I'll explain this to you a bit later when we are understanding decimal binary to decimal conversion. But for now, let us understand and re-verify whether we are right or not. So this is 1 2 3 4 5 6 7 8. So this is okay, let me check once. Right. Five, 6, 7, 8. So 2 raised to 7, which is 2 raised to 4 is 16, 32, 64. Something is wrong here. Okay. All right. I guess something is wrong here, so let's try to do it again. Okay. I believe something went wrong while we were dividing. Let's re-verify it again. Okay. 2 threes are 6, and then we have 2 nines are 18, 2 ones are 2, 2 nines are 18, 1, 2 nines are 18, 1, 2 fours are 8, 1, 2 twos are 4, 0, 2 ones are 2, 0, 2 zeros are 0, 1. So 1, 0, 0, 1, 1, 1, 1. Alright, that is correct. So that means 79 in decimal is represented like this in binary. Okay, so this was the first conversion. Basically, you just divide the decimal number system by the base. Now, what if your number has a fractional part? Let's say 79.25. What if it has a fractional part? How do we convert this number from decimal to binary? Or let's say any other number system which has a different base. Okay, so remember this. For the integer part, now what's the integer part in 79.25? It's 79, which is the integer part. What about 0.25? That becomes the fractional part. Just remember, whenever such a problem comes, always deal with integer part separately and the fractional part separately. So for the integer part, what we do is basically divide by the base. That is what? Divide by 2 when we are converting it to binary. So we'll perform the same operation, that is divide by 2, collect the set of remainders, look from bottom to top, and the set of remainders will be the number that you're looking for. What about the fractional part? For the fractional part, always multiply it by the base. Okay, let me write it down here. Always multiply it by base. Multiply by base. Now what do I mean by this? Okay, let's say we have to convert 0.25, which is in decimals, to binary. Now this is a fractional part. What do we have to do? We have to multiply this thing by base. What's the base that we want to convert it into? It's 2. So multiply 0.25 with 2. What does it become? 0.50. Again, take this answer, multiply it by 2. What will it become? 1.00. Now, why did we again multiply 0.50 by 2? Why did we do it? Now, the very purpose of multiplying the fractional part by 2 is to get the fractional part as 0. Once you get the fractional part of 0, that is where you stop. That's it. Alright. Now you while what we did in the integer part was we went from bottom to top. Now in the fractional part, just go from top to bottom. So what we have 0, 1. Okay, we have 0, 1. That's it. So your fractional part, that is 0.25, can be written as 0, 1. Okay, it can be written as 0, 1. That's it. Now this thing is in binary. So 0.25 in decimals will become 0.01 in binary. So what's the whole number? 79.25 in decimal should be written as, we had the integer part, 100 4 times 1. We'll write it here, 100 4 times 1.01, which is your fractional part in binary. So this is the whole number that we are looking for. Okay, this is the whole number that we are looking for. So this is how you convert a decimal number into a binary number. For integer part, deal with it separately. For fractional part, deal with it separately. For integer part, divide by base. For fractional part, multiply by base. And it's universal for any number system when we have to convert from decimal to any other number system. Okay, from decimal to any number system, just divide the integer by base and multiply the fractional part by base. That's it. We just saw for binary, and we will see for the other number systems like octal and hexadecimal in a separate video. That was it for now. See you in the next video.